Hi everyone, this video is about one of the biggest misconceptions I see out there in the web. I often get asked in my courses, for example, whether it is safe to store an authentication token in local storage, because local storage is vulnerable to cross-site scripting attacks. Now in this video, I'll show you why yes, it's vulnerable, but why no, cookies are not better and will not protect you against cross-site scripting attacks and users stealing your tokens. So let's jump in and let's find out what the most secure storage mechanism is when it comes to storing authentication data. So here you have an example application. You find a link to the code below the video. And below the video, you also find a detailed article, by the way. And in this example application, we have a backend. This is this app.js file. This holds a simple Node Express application, a very simple one with 3 routes which are supported, where I in the end have one route that needs authentication, where I'm looking for a token in various ways. I'll come back to that. And then I have 2 routes for authenticating the user, one route that sends back a token, and one route that sends back a cookie. I will explain this cookie route in more detail later as well. We also have the frontend folder, and there we have a very simple frontend application, a HTML file with a script import, a style import, and some HTML content here, of course. Styling is applied here in the style CSS file, and app.js, that is now the frontend code in the frontend folder. That's the JavaScript code which interacts with the HTML page. And here I'm not using any framework or library. Instead, this is really just plain vanilla JavaScript code, which connects these buttons here, the form here, and in the end makes sure that we can enter some data into that form and output what we entered here. Now let's see this in action. And for that, run npm install in the root folder of this entire application. And thereafter, node app.js to start this root level app.js file with Node.js. For that, of course, you need to install Node.js. So make sure you did that first on nodejs.org. You can simply download the latest version, walk through the installer, and you got Node.js on your system. With that, you can run this server here, and this server also serves the frontend. So if you now visit localhost 3000, you should see this application here. Now let's ignore the 2 buttons at the top here. Instead here, we can enter a message, add an image URL. So here I'll just pick any image, it doesn't really matter. Copy image address, enter this here, click submit, and this sets this message down there and displays it. Nothing too fancy, that's just some client-side JavaScript doing its job. Now let's imagine that this is an application which also has users sign up and log in, and whenever we do sign up or log in, we get back a token from the backend. This is a typical pattern you have in modern web applications where you have a separated client side, for example, a single page application with vanilla JavaScript or with a library like React or Angular, and then a server side, which is a API, often a REST API. And that's basically what we have here as well. App.js holds the Node Express code, and in there we have a very simple REST API with 3 key endpoints in the end: /userdata, /authenticate token, and /authenticate cookie. We can set GET requests to these paths and we'll get back a response in JSON format. That's a very simple REST API. And we have the standalone frontend, which is this HTML file, the CSS file, and this JavaScript file. So it's a very typical application. And let's now imagine that as part of this application, we also had users sign up and so on. I didn't fully implement it here because I want to focus just on that client-side storage. Therefore, at the moment, we can send a GET request to authenticate token and we'll just get back a token as part of the response. And the token is just ABC. In reality, this would be a route that wants a username and a password, for example, verifies that data with your database, and if the data is correct, it would generate a secure token, which can only be verified by the server, and it would send back that secure token, typically in the JSON web token format. That's how it would work in reality. That's what you see in detail in my Node.js course. But here, this dummy approach will do. Now in the frontend app.js file, we got a couple of functions here which are triggered on different button clicks. And when we click fetch token and save, we basically simulate that sign up process. Because when we click this button, initially the get and save token local storage function is being triggered. And that is simply this function here, which sends a GET request to /authenticate token on my REST API here, and then stores the token we get as part of the response simply in local storage. And when we then later click send request with auth data, it's this send data function that will be triggered. There we load the token from local storage. So that's this function here, which simply gets the token from local storage and then sets the loaded token variable, which we have up here, equal to the token it found. And we need that loaded token thereafter because when we then send a request to the potentially secured data, so to that endpoint that needs a token, we add the token through that authorization header to the outgoing request, and then we either get back a success or a failure response depending on whether we added a valid token or not. Because on the backend code here, on/userdata, I'm looking for that token in the authorization header. If I'm not finding it there, I'll look in the cookies, but I'll come back to that. For the moment, looking it up in the header should work. And once we got the token, I check if the value is ABC, and if it is, I send back a success response, otherwise the error response. Of course, that's just some dummy code. Again, in reality, we would verify if the token we get is a valid JSON web token, but here it's just about the client-side storage, so this dummy token will do. Therefore, if you save that and you reload here, initially, when we didn't fetch any token, if I click the button, I get the unauthorized error. If I click fetch token and save first, and then I try this again, we succeed, because now we did fetch the token, save it, extract it before we send the request, and then added it to the outgoing request. This is a default authentication pattern you have in many applications. Users are signing in, and you're then storing some token that identifies those users in local storage, and you're adding that token after fetching it from local storage to outgoing requests. Now, people might argue that this is insecure. Why? Because of cross-site scripting attacks. Here, you can enter a message, we can enter an image URL. Now, that data is rendered to the screen through this render user input function in the frontend app.js file. And there you see in the end, I'm just setting some inner HTML to this string where I inject the user-generated content. This screams for cross-site scripting attacks. Now, you might think that we can't just enter a script like this and we're good, but it's not as easy as that. This does not execute. This code does not execute. Browsers, modern browsers, are smart enough to prevent this, but you shouldn't rely on this protection. There might be browsers out there which do execute such injected code. But there is a way of tricking even modern browsers. Let's set an image here which does not exist. I'll set the image URL to not there. This does not exist.com/noimagefound.jpg, which is a URL and an image that shouldn't exist. And then I add a double quote here. Because ultimately this here is just some text, right? We're generating a string here, which we then set as inner HTML. What if we would manipulate that string? And that's what I'm doing here. I'm closing the source attribute value with this extra double quote. And now I can simply add a new attribute, on error, for example, which is an attribute that does exist on image elements. And on error wants JavaScript code that should execute if that image fails to load. Now, by forcing this to happen, by using an image that does not exist, I can now, for example, execute my alert code here. We don't need a closing double quote because that's this double quote, which we have in the original string. Keep in mind that whatever I entered here is now simply inserted here. So if I temporarily just copy this in, you see now this is my source, it's closed here, and then we have on error. looks quite normal, right? That's what we're generating now with this approach. If I now click submit, we get that alert. And now, boom, here we are. This is a cross-site scripting attack in action. We're now running our JavaScript code on this page. Now, currently, of course, I'm only hacking myself. I only got access to my own page here. That's not too valuable. But typically, of course, such user-generated content would be stored in a database, right? It's not the case here to keep this app simple, but typically that is what would happen. This data here would be stored in a database. And then it might be served to other users as well. And all those other users then get my code, and my JavaScript code executes on the machines of those other users through that website. And that is where the problems begin. Now, what can I do here? Well, let's come back to the tokens. The token is stored in local storage, right? We can see that in the browser DevTools under Application, Local Storage. Here's the token. The local storage API is accessible in JavaScript. We did use it to store the token and to get it after all. Right here, we're working with local storage. Well, I can do this here as well. I can get the token with local storage, get item for the key token, and then I could console log it, but of course in reality, I could also send it to my own server. So to the bad guy's server. And there I could store all those tokens by all those users and use them to get access to those user profiles, to place orders on behalf of those users, to do a bunch of bad stuff. Here I'm just logging it to show you that it works. If I submit this, we see ABC here in the log, and that proves it. We can extract that token through cross-site scripting. And that's bad, isn't it? This is a security hole in the application and we're abusing it. So local storage is bad, right? Well, we'll find out if local storage is bad. Let's see what the alternatives are. And the alternative we have essentially is that we use cookies. Local storage is a browser storage we can use. Cookies is another storage. Now, I already prepared the code for that. In the front-end file, you can simply go down here and comment out this get and save token local storage line and comment in get and save token cookie, so line 67. And in send data, comment out load from local storage and comment in load from cookie. Now, what these two functions do is the following. Get and save token cookie gets the token still from the same URL as before on the backend. So it's still this endpoint which sends back the token. But now we don't store the token in local storage, but instead in a cookie through JavaScript with this code. This is regular client-side JavaScript code for writing a cookie, and I'm writing the token cookie to store my token. And load from cookie simply holds some code that looks into all my cookies, finds the token cookie and gives me the value and stores the value in the loaded token variable, which we then use for sending data and adding the token in the authorization header. So we're just storing it in cookies instead of local storage. That's the only difference. If we save that, I'll copy this attack pattern code here, reload the page, and if I now try to send a request, this crashes. Actually, my entire backend crashed because it's not prepared to not get any token or anything like that. Of course, we could harden the backend, add some error handling here, but that's not what this is about. So I'll just restart the server because the backend is not our problem here. The front end is the problem. And there, at least we see, we weren't able to get the user data without a valid token. And since we're now using cookie storage and we never stored a token in there, we can't get access to the user data. So that's working as intended. Let's now click fetch token and save and then try again. Now sending a request succeeds and we get back the secret data because now I first fetched the token, stored it in my cookies, and then used that token extracted from the cookies to attach it to the outgoing request, send it to the backend, and get my secure data from there. In the application tab, we can also see this. There under cookies, we see the token cookie was set. Now, is this protected against cross-site scripting? Let's insert the code and let's manipulate this code for extracting the token a little bit. Instead of accessing local storage, I will just repeat what I'm already doing in the app.js file in the frontend folder. There in load from cookie, I got this code here, which in the end does just what the name implies. It goes to my cookies and tries to find the token there. So if that works here, it should also work here. So I'll set token equal to this code. Just get rid of that white space here, of course, to ensure that this all works properly. And with that, if I submit this, again, I print my token here. And again, here I'm printing it. I could have sent it to my own server instead. So cookies are also vulnerable to cross-site scripting attacks. They're not better than local storage, right? Well, I know that some of you are already there to send me some messages and tell me how stupid I am, because this is obviously the wrong kind of cookie. I was doing it wrong. Well, let me prove you wrong now. This is definitely not a secure cookie. I agree. But what would be a better cookie? A HTTP-only cookie. And my code is prepared for this as well. The app.js backend file, so the root level app.js file, has this authenticate cookie route. And in there, we do something different. I'm not sending back a token. I just send back a message. But on the response, I do set a cookie. I set the token cookie to my ABC value, and I set the HTTP-only flag on that cookie. This means that this cookie is part of the outgoing response, and it will automatically be managed by the browser and will be stored there. But my JavaScript code in the client will not be able to interact with that cookie. It's not able to write or read it because it's marked as HTTP only, which essentially means that this cookie is only accessible on the server side, not on the client side. So this should be good, right? The question, of course, is how do we then attach it to the outgoing request if we can't read it in client-side code? Well, let's go to the client-side code. There, first of all, comment out the get and save token cookie function here, and comment in line 68, this line. In send data, comment out load from cookie and leave both lines here commented out. So I'm not loading the token anywhere in my client-side code anymore. But there's one important thing you gotta know. When sending a request with fetch to the same domain your app is being served from, which in this case is the case, the app is served on localhost 3000, and that's also the domain to which I'm sending a request, then all your cookies, all your HTTP-only cookies as well, will be included automatically by the browser on that outgoing request. So that authorization header will not be set, loaded token will be undefined. But instead, the cookie itself will be part of the outgoing request, and that's why I prepared my backend server to not just check the authorization header, but, if it doesn't find a token there, to also check the headers of the incoming request. Because as I just said, the browser will automatically add my cookie there. Because of all that, if we save the frontend code, I will also save my cross-site scripting attack code, and I then reload, it initially won't work. If I go to application here, and I clear my token there, and also under local storage. If I now try to send this request, you see it fails. And my backend again crashes because it doesn't have proper error handling logic for this. Let's restart the backend therefore. And let's now try it with fetching the token and then sending again. Please note that here I didn't get the token. Instead, if we go to the network tab and we have a look at this request here, this one, you see that on the response, we simply have that set cookie header, which sets this token cookie automatically with the HTTP only flag. Therefore, now if I send a request with auth data, we get the success message because on the outgoing request to that secure data route, we see on the request headers, the cookie was attached, and therefore on the server side, we could extract it and use it there. Now, since I said that the client-side JavaScript code can't read this, this should be secure, shouldn't it? Let's try again. Here's my code which worked before. This is the code for a cross-site scripting attack that extracts the token. Now, if I run this code, you see it just fails and I don't print the token here. The reason for that can be seen in the application tab of the DevTools under cookies. You see the httpOnly flag is set for this token now, and as I said multiple times, therefore client-side JavaScript code can't read it. So we're done. This is safe. Local storage is a bad idea, right? No, this is not correct. We can still use this cross-site scripting security hole here to mess with your users, to steal their data, to even steal their tokens. And here's how that works. I got a second server, the bad guy backend. It's a simple Node-Express server, has only 21 lines of code, and I set some CORS headers here to allow for cross-site requests, so that I allow localhost 3000 to send a request to this server, which will run on localhost 8000, which is a different domain, and I expose one endpoint, /steal data for a GET request, and there I try to get the cookie, and then I just log it. So I try to get the token cookie, I should say. Now this is a totally different server. This is a server which I, the bad guy who's attacking your page, own. I own this server. And typically when I launch an attack against your site, I will probably have such a server to which I can send the tokens which I previously stole from local storage, or to send any other kind of data I stole. So I have this server, and I can now start this server here with node bad guy backend.js. The other server is also still running. App.js is the good server, your server, which I'm attacking. Bad guy backend.js is my server. So I am the attacking guy here. Both servers are running now. And now here, I will change this code a little bit. On error, I'll simply send a request with the fetch function which exists in JavaScript. I'll send it to localhost 8000/steal data. Now like this, it actually wouldn't work because by default, when you're sending a request to a different domain than you're currently running on, so in this case to 8000 when we're running on 3000, cookies would not be attached. That's the default mechanism. That's a security mechanism. But we can configure fetch to attach it. I can set a second argument on fetch, and there we can set credentials to include, to the string include. And with that, we tell the browser that we want to ignore the default security settings, and we do want to add cookies to the outgoing request, even though it targets a different URL. Now, sometimes you want this because it is quite common that your front end runs on a different domain than your backend. Here, of course, it's a problem because I have a bad backend here to which I still can send this request. Now, the backend needs to be configured correctly. I need to allow specifically that domain which I'm attacking. Of course, as an attacker, I do know this domain, so allowing access from it is not hard. And I need to add this access control allow credentials header here on my request to allow that attacked domain to give me its credentials. Ain't I generous? So, on my backend server, on the bad guy backend server, I'm prepared to let the good guy send me all his data. And with that, if I now click submit here, and we go to the network tab, we see that worked. The request was sent. And if we have a look at the request headers, we see the cookie with the token was part of it. And it's now on my server. And I'm the bad guy. Now, of course, I don't even need to send that token, or not just the token. Since I have access to your page through that XSS security hole, I can execute any code here. I could hit your own server with the token of the user. Keep in mind that it's attached to outgoing requests to your own server automatically. And I can get data about your user and then just send that user data to my bad guy server. I can do anything I want if I have access to your server or to your code through cross-site scripting. And that's why local storage is actually not more insecure than cookies. Because whilst it's not as straightforward to steal a HTTP-only cookie, You also see it's not hard once you know how it works, and you hopefully don't think that people attacking your page wouldn't know how it works. So therefore, the question is not whether you should use local storage or cookies. The question is whether you're vulnerable to cross-site scripting attacks, and you should absolutely do everything you can to protect against that. Make sure you sanitize and escape all user-generated content. Never directly use user-generated content without double-checking it. Sanitize it before you output it. Libraries and frameworks like React and Angular do that for you. But on your backend, also sanitize it before you store it in any database. Here, we're not storing it in a database, but if you are, sanitize it. There are libraries that help you with that basically remove any JavaScript code in your user-generated content so that you're only storing content that does not hold attack patterns like this. This is what matters. Local storage versus cookies is the wrong discussion. We should only protect against cross-site scripting attacks, because if you're vulnerable to that, you're in deep trouble anyways.